music theory, the word inversion has several meanings. There are inverted chords, inverted melodies, inverted intervals, and inverted voices. The concept of inversion also plays a role in musical set theory. Intervals. An interval is inverted by raising or lowering either of the notes using displacement of the octave so that both retain their names. For example, the inversion of an interval consisting of a C with an E above it is an E with a C above it. To work this out, the C may be moved up, the E may be lowered, or both may be moved. Under inversion, perfect intervals remain perfect, major intervals become minor and vice versa, augmented intervals become diminished and vice versa. Traditional interval names add together to make 9, seconds become sevenths and vice versa, thirds become sixes and vice versa, and fourths become fifths and vice versa. Thus a perfect fourth becomes a perfect fifth, an augmented fourth becomes a diminished fifth, and a simple interval and its inversion, when added together, equal an octave. See also complement. Chords. A chord's inversion describes the relationship of its bass to the other tones in the chord. For instance, a C major triad contains the tones C, E and G. Its inversion is determined by which of these tones is the bottom note in the chord. The term inversion is often used to categorically refer to the different possibilities, although it may also be restricted to only those chords where the bass note is not also the root of the chord. In texts that make this restriction, the term position may be used instead to refer to all of the possibilities as a category. Root position. A root position chord applier is sometimes known as the parent chord of its inversions. For example, C is the root of a C major triad and is in the bass when the triad is in root position. The third and the fifth of the triad are sounded above the bass. The following chord is also a C major triad in root position, since the root is still in the bass. The rearrangement of the notes above the bass into different octaves and the doubling of notes is known as voicing. Inversions. In an inverted chord, the root is not in the bass. The inversions are numbered in the order their bass tones would appear in a closed root position chord. In the first inversion of a C major triad applier, the bass is the third of the triad with the fifth and the root stacked above it, forming the intervals of a third and a sixth above the inverted bass of E, respectively. In the second inversion applier, the bass is the fifth of the triad with the root and the third above it, forming a fourth and a sixth above the bass of G, respectively. This inversion can be either consonant or dissonant, and analytical notation sometimes treats it differently depending on the harmonic and voice-leading context in which it occurs. For more details, look at second inversion. Third inversions exist only for chords of 4 or more tones, such as seventh chords. In a third inversion chord applier, the seventh of the chord is in the bass position. For example, a G7 chord in third inversion consists of F in the bass position, with G, B and E above it being intervals of a second, fourth and sixth above the bass of F, respectively. Notating root position and inversions, figured bass. Figured bass is notation convention used to specify chord inversion, in which Arabic numerals are written below the bass note of each chord in a harmonic progression, expressing the intervals resulting from the voices above it. For example, in root position triad C-E-G, the intervals above bass note C are a third and a fifth, giving the figures 5-3. If this triad were inverted, the figures 6-3 would apply, due to the intervals of third and sixth appearing above bass note E. Figured bass is similarly applied to seventh chords, which have 4 tones. Certain arbitrary conventions of abbreviation exist in the use of figured bass. In chords whose bass notes appear without symbols, 5-3 position is understood by default. First inversion triads are customarily abbreviated as 6, that is, presence of the third is understood. Second inversion triads are not abbreviated. Root position seventh chords, that is 7-5-3, are abbreviated as 7. First inversion seventh chords 6-5-3, are abbreviated as 6-5. Second inversion seventh chords 6-4-3, are abbreviated as 4-3. Third inversion seventh chords 6-4-2 are abbreviated as either 4-2 or simply 2. Figured bass numerals express distinct intervals in a chord only as they relate to the bass voice. They make no reference to the key of the progression. They do not express intervals between pairs of upper voices themselves. They do not express tones in upper voices that double, or are unison with, the bass note. However, the figures are often used on their own in music theory simply to specify a chord's inversion. This is the basis for the terms given above such as chord. Similarly, in harmonic analysis the term I6 refers to a tonic triad in first inversion. Popular music notation. A notation for chord inversion often used in popular music is to write the name of a chord followed by a / and then the name of the bass note. For example, the C chord above, in first inversion may be notated as CE. This notation works even when a note not present in a triad is the bass. For example, FG is a way of notating a particular approach to voicing an F9 chord. Lowercase letters may be placed after a chord symbol to indicate root position or inversion. Hence, in the key of C major, the C major chord below in first inversion may be notated as IB, indicating chord I. First inversion. If no letter is added, the chord is assumed in root inversion, as though have been inserted. Hindu Arabic numerals. A less common notation is to place the number 1, 2, or 3 after a chord to indicate that it is in first, second, or third inversion respectively. The C chord above in root position is notated as C, and in first inversion as C1. Cadential 6/4 chord. The cadential 6/4 is a common harmonic device applier that can be analyzed in two contrasting ways. The first labels it as a second inversion chord. The second treats it instead as part of a horizontal progression involving voice leading above a stationary bass. In the first designation, the cadential 6/4 chord features the progression I6, 4, B, I. Most older harmony textbooks use this label, and it can be traced back to the early 19th century. In the second designation, this chord is not considered an inversion of a tonic triad but as a dissonance resolving to a consonant-dominant harmony. This is notated as V6-5, 4-3, I, in which the 6/4 is not the inversion of the V chord, but a dissonance that resolves to V5, 3, that is, V6, 4, B. This function is very similar to the resolution of a 4/3 suspension. Several modern textbooks prefer this conception of the cadential 6/4, which can also be traced back to the early 19th century. Counterpoint, contrapuntal inversion requires that two melodies, having accompanied each other once, do it again with a melody that had been in the high voice now in the low, and vice versa. Also called double counterpoint, or triple counterpoint, themes that can be developed in this way are said to involve themselves in invertible counterpoint. The action of changing the voices is called textual inversion. The inversion in two-part invertible counterpoint is also known as rivolgimento. Invertible counterpoint can occur at various intervals, usually the octave, less often at the 10th or 12th. To calculate the interval of inversion, add the intervals by which each voice has moved and subtract 1. For example, if motive A in the high voice moves down a 6, and motive B in the low voice moves up a 5th, in such a way as to result in A and B having exchanged registers, then the two are in double counterpoint at the 10th. (1 = 10). Invertible counterpoint achieves its highest expression in the four canons of J.S. Bach's art of fugue, with the first canon at the octave, the second canon at the 10th, the third canon at the 12th, and the fourth canon in augmentation and contrary motion. Other exemplars can be found in the fugues in G minor and B-flat major, external shockwave movies from Book 2 of Bach's Well-Tempered Clavier, both of which contain invertible counterpoint at the octave, 10th, and 12th. Melodies. When applied to melodies, the inversion of a given melody is the melody turned upside down. For instance, if the original melody has a rising major third, the inverted melody has a falling major third. Cm. 24 of Bach's Cm Fugue, external shockwave movie, Well-Tempered Clavier 2, for an example of the subject in its melodic inversion. Similarly, in 12-tone technique, the inversion of the tone row is the so-called prime series turned upside down, and is designated TNI. Given a certain prime set, with general element pi, j. Under the inversion operation, pi, j, pi, 12, j. That is, each element of the prime set is mapped into an element with identical order number but with set number the complement, sic of the original set number. Each element P of a given set P is associated with one and only one inverse element S equals P in the universal set S. For each U and V in S, we shall define an operation of U, which we shall call UV inversion. W, E conceive any sample S and its inversion I, S, as balanced about the given U and V in a certain intervallic proportion. I, S, bears to V in intervallic relationship which is the inverse of the relation that S bears to U. Inversional equivalency or inversional symmetry is the concept that intervals, chords, and other sets of pitches are the same when inverted. It is similar to enharmonic equivalency and octave equivalency and even transpositional equivalency. Inversional equivalency is used little in tonal theory, though it is assumed that sets that can be inverted into each other are remotely in common. However, they are only assumed identical or nearly identical in musical set theory. All sets of pitches with inversional symmetry have a center or axis of inversion. For example, the set ca euro a euro fa unregistered trademark a euro ga euro b has one center at the dyad f and fa unregistered trademark and another at the tritone, bc. If listed fa unregistered trademark a euro ga euro bar euro ca euro a euro f. For ca euro a unregistered trademark euro a euro fa unregistered trademark a euro ga euro bar unregistered trademark the center is f and b. If listed fa unregistered trademark a euro ga euro bar unregistered trademark euro ca euro a unregistered trademark euro e. Musical set theory. In musical set theory, inversion may be usefully thought of as the compound operation transpositional inversion, which is the same sense of inversion as in the inverted melodies section above, with transposition carried out after inversion. Pitch inversion by an ordered pitch interval may be defined as which equals. First invert the pitch or pitches, x equals ax, then transpose, ax plus n. Pitch class inversion by a pitch class interval may be defined as inversion about a pitch axis is a compound operation much like set theory's transpositional inversion, however in pitch axis inversion the transposition may be chromatic or diatonic transposition. Pitch axis. In jazz theory, a pitch axis is the center about which a melody is inverted. The pitch axis works in the context of the compound operation transpositional inversion, where transposition is carried out after inversion. However, unlike musical set theory, the transposition may be chromatic or diatonic transposition. Thus if DAG is inverted to DGA, the pitch axis was or will be D. However, if it is inverted to CFG, the pitch axis is G, while if the pitch axis is A, the melody inverts to EAB. Note that the notation of octave position may determine how many lines and spaces appear to share the axis. The pitch axis of DAG and its inversion ADE either appear to be between C bar and registered trademark or the single pitch F. History. In the theories of Rameau, chords in different positions were considered functionally equivalent. However, theories of counterpoint before Rameau spoke of different intervals in different ways, such as the regola del terzi sest, which required the resolution of imperfect consonances to perfect ones, and would not propose a similarity between 6, 4 and 5, 3 sonorities, for instance. See also, voicing, pitch axis theory, retrograde inversion, references.